Hey there, welcome to a video on section 6.2 regarding the properties of rational exponents. So this is going to be an extension of what we did in 6.1 when we talked about just rational exponents in general. So remember what we talked about earlier, if you have like the nth root of a, that's a to the 1 over n power. Or if we look at this one, of the nth root of b, that's b to the 1 over n power. So if we think about it, if you have a to the 1 over n times b to the 1 over n, we could probably just lump A and B like this and put the 1 over n on the outside. And that's exactly what's happening on the left side of that property right there. So that's something we can do. Likewise with ratios of A and B, if you have the nth root of A over B, you can separate as the nth root of A over the nth root of B. So armed with this knowledge, let's kind of go through these problems right now. Here I got the cube root of 12 and 18, so I can multiply those two together. And if you use a calculator, I believe that's going to be 216. Well, we did talk about this earlier. The cube root of 216 is 6. We actually know what that is. Here, we can combine 80 and 5 like this. A over 5 is 16. And we do know the fourth root of 16 is just 2. Now, sometimes we run into some situation like this here, 135. I can't think of three numbers that multiply to 135. But I could break it up like this. If I divide by 3, I get 3 and 45. If I divide 45 by 3, I get 3 and 15. If I divide the 15 by 3, I get 3 and 5. So apparently 135 is the same thing as 3 cubed times 5. So when I take the cube root of 135, I'm really taking the cube root of 3 cubed times 5. If I break it up, the cube root of 3 cubed, those are just going to cancel each other out because that's cube root of 27, which is 3. And you get that. So what you're doing is you're looking for a factor that is a perfect root. Sometimes we talk about perfect square roots. In this case, we're looking for a perfect cube root. So let's look at h. That's yet another one we can look at. And I'm not sure what happened to A, B, and C. I guess those got skipped. So, okay, just want to make sure I didn't leave anything out. So 64. You know, that's 4 and 16. It's 4 and 4. So obviously we know it's 4. So that's going to be 4y squared. The reason why is because you're getting 64 y to the 6 raised to the 1/3. So 64 to the 1/3, and then y to the 6 to the 1/3. Using our properties of exponents, 6 over 3 is 2, and the cube root of 64 we know is 4. So it's, yet again, we're using this property that we just discussed not too long ago. That's also cube root. If you distribute it, you do 27 to the 1/3 times p1 times q4. You have 3p q4. Here, you're in the fourth root of m4, fourth root of n8. It's m over n squared. We'll keep moving. This one's a little weird. You have the cube root of x, and that's going to be cube root. You can break it up like this. Y6 times y2 is y8, and y6 is that's going to come out clean. If you take the cube root of it, it becomes y squared. Now this part's a little tricky. What you're going to do is you're going to multiply both top and bottom by the cube root of y. The reason why is that you want this to become a perfect root, meaning that you don't want any radicals in the bottom if you're trying to rationalize it. Because there's already two y's here, you need one more y to make it a perfect, so that it becomes a multiple of 3. So when I work that out, I get the cube root of x times the cube root of y, so I actually can combine it like this. And the bottom I have y squared times y, which of course is y cubed. If I look at L, 14 over 2 is 7. If I subtract these exponents here as x1 over x 3/4, y to the 1/3, and the z negative 6 can actually come to the top and be z6. So 7x to the 1/4 times y to the 1/3 times z6. If you want to write radical form, you could write a 7/4 root of x times cube root of y, and of course times z6. You can't combine the fourth root and cube root, you kind of have to leave them separate, but this is fine too up here. I'm going to need a little more space. So that was the fifth root of 32a4b10. So you have the fifth root of 32 times the fifth root of a4, and then times the fifth root of b10. The fifth root of 32 now is just 2. And here, you just leave it. But this becomes b2. That's because you're doing b10 raised to the 1/5 power, which is b2. So we have 2b squared times the fifth root of a4. And this will be kind of important when we get to pre-calculus, you start dealing with like more simplifying problems. Sometimes you do have to kind of clean up what you're dealing with radicals, and so it's a good skill to have. So let's talk about solving equations. These are a little more exciting, I think. So we got 3 more examples, and I'll wrap up this video. So here we'll divide both sides by 2. And remember, that's anything that 1/2 powers of square roots. But what you could do is that after you isolate this part right here, you can just square both sides, get rid of that, and x equals 5. You should check your work. So it's 2 times 9 to the 1/2 equals 6. 2 times 3 equals 6. 6 equals 6. Awesome. Let's say I divide by 2 now. This one here. So I get -3. But here's the dilemma. I know x plus 4 raised to the half is a square root. Squares can't equal negative numbers. But if you were to square it, you're going to be a little bit deceived. Because what's going to happen is you're going to have x plus 4 equals 9. You're going to still think the answer is 5. The problem is that when I check my work, you have 2 times 3 equals -6. 6 does not equal -6. That's not okay. So in this case, we'd say this is no solution. And that gives rise to something that we see at the bottom here called extraneous solutions. It's when you raise each side of an equation to the same power, it may introduce extraneous solutions, something that won't work. Seems like it works. But it doesn't. A little deceiving. That's why you got to check each side. Now, why that happens, that will be more clear once we get to graphing. But I'll kind of give you a quick teaser, but if you were to graph something like this and graph a line, if they don't touch, of course, there's no solution. That's kind of what's happening here. Of course, if they do touch, if you have a point of intersection, that's a solution. So that's kind of what we're noticing is that if you were to graph one side of the equation, graph the other, and they're not going to touch, and we have to say no solution. But we haven't done graphs of radical functions yet, so I know that might not be totally clear just yet. Okay, last bit. What you want to do is isolate the radical, which it already is. I'm going to square both sides. 2x plus 3 equals x squared. You don't have to FOIL it. Minus 12x plus 36. Remember, that's x minus 6 times x minus 6. Through there on the one side, x squared minus 14x plus 33. Fortunately, we can do x minus 3 and x minus 11. X equals 3 or 11. But you got to check your work. If I plug 3 in, you're going to have a problem. You're going to have root 9, which is 3, but you're going to have negative 3 on the other side. So that's extraneous. If I plug 11 in, 22 plus 3 equals 11 minus 6. Root 25 equals 5. 5 equals 5. Boom, there you go. So 11 works. So what I'm going to ask you guys to do after this video is over is to go to page 5, and you'll see that there's 8 problems here. In the Google form, keeping it pretty simple, I'm just asking to provide the answers for me for a few of these problems here. And I'm going to have you give me the answers for numbers 1, 2, 3, and 4. Now I'm going to give you a hint. What you're going to want to do for number 1 is raise both sides to the 2/3 power. Actually, I'll that's very quickly. So you're going to want to raise both sides to the 2/3 power. You should be able to figure this one out. Here you guys subtract the 5 first, and then square both sides. Remember, you have to isolate the radical. And if you think about it, we have since the 3 has power, that is part of a radical, so it was very isolated for number 1 to begin with. Isolated for number 3 here. Isolated for number 1 here, and of course, check your work. So I'm only going to ask you guys to do 1 through 4, and then submit, and then in the Google form, I'll just ask you to give the answers for those 4. The other 4 problems, 5 through 8, we'll just do in class when we meet again. So yeah, enjoy Super Bowl, have a great weekend, and I'll see you guys on Monday. And of course, stay safe and dry. The roads are really wet out there.